Ladies and gentlemen, it's a pleasure to be here with you today. Let me introduce myself first. I am Mingwei Shi, a second-year computer science student from Trinity College, Dublin. My talk today will cover empathetic dialogue system. To begin with, I will be speaking about the components normally found in our paper, the background and significance of topic selection, mirror neuron, artificial mirror neuron network, and empathetic protocol. I will think of an empathetic protocol to address this issue via introducing an innovative element, mirror neuron, from connection design and neuroscience to gradually design an artificial mirror neural network in the dialogue system for clear interpretability. And then our work will describe an empathetic protocol to produce and analyze responses between a user and an agent via the self-defined neural network that served as the central nervous system of a dialogue agent. By employing this protocol in a traffic service application, users will feel that their emotions were resonating with and understood, and then communicate with the agent proactively. Now let's move to the first main part of my talk, which is about the background and significance of topic selection. As the dialogue systems becomes more and more popular, such as Microsoft Cortana, Amazon Alexa, users not only satisfy getting responses from chatbot, but also need to establish a tie and interact with chatbot emotionally. But most of applications have issues, such as semantic understanding and inconsistency in personality issue. Based on this issue, I'm thinking of some thoughts from following previous work. Emotional research, open domain chatbot, task-specific chatbot, and text generation. By thinking out these points, it is easier for me to think out how to design a protocol in a dialogue system in our work. Now, let's enter into mirror neuron part. This idea is coming from the mirror neuron in F5 region in our brain, which served as an empathetic function in our brain. Clearly see that women have strong empathetic mechanisms than men because of that. This is only a joke. For our model, you can see the left part of the picture. I use final state machine to represent the mirror neuron in the rest of two pictures. And this is the only definition of our artificial mirror neuron. And then the rest of two pictures shows the two precises of our mirror neuron. And when the initial mirror neuron receives the intention from a user, we need to convert and pass the original signal into kernel of mirror neuron, which has a role for buffering and pre-processing mirror neural signal. After pre-processing the kernel of mirror neurons, the output signal passes to next ones or merges to the other ones. Now let's move to the next section. Artificial mirror neural network in this section includes multiple mirror neuron in the previous section. Knowing the penalty and reward mechanism of our artificial mirror neuron will help us to know the whole network better. Two emotions are in the picture affecting the approach of connection of a single mirror neuron, sympathy and empathy. A sympathy is an act of entering into or sharing the feelings of another. On the other hand, empathy identifies thoughts and acknowledges an awareness of one's separateness from the observed. In the other words, empathy triggers us to help others, which originated from the unintentional behavior rather than self-interest. Empathy is also a sound quality in human beings, and find a goal in the dialogue system. For the artificial mirror neural network in this paper, I set a reward and punishment system. When the mirror neuron responds to the sympathetic feedback, the synapse in our mirror neuron will shrink and accept punishment. When it applies to sympathetic feedback, the synapse will extend. So fully understand user emotions and give them resonating response is important stuff. And in the next picture, the artificial mirror network combines multiple single neuron via transmission approach, just like merging and passing the previous pictures among different single mirror neurons. Every circle in the figure represents a group of mirror neurons with a specific functionality, and line shows the relationship between different mirror neuron groups. Artificial mirror neural network have 4 layers, which take reference from the layer in the TCP/IP protocol: input layer, person layer, iteration layer, and output layer. Initially, when users use our dialogue system, messages from users are translated into initial mirror neurons, providing functionality for buffer and original utterance served as the input layer. The following layer is a person layer, mainly for the parsing and calling specific functionality of neurons according to the original utterance in the first layer. This layer starts with separating emotion corpus and non-emotional corpus. Emotion corpus is a phrase with a visible or invisible emotion phrase or sentences. Where non-emotion corpus is the content and background of the current conversation. Generally, when user has a negative emotion, the mirror neurons for negative emotion will be activated. This neural group recognize different negative emotions via a structure where its emotion knowledge graph constitutes different emotion neurons. You can see in the picture, I defined 4 classifiers for negative emotion: sorrow, pain, anger, and depression. Correspondingly, the positive emotion neuron groups with the same structure utilize positive neurons and generate a supportive corpus to comfort user adverse feelings. Simultaneously, the content corpus neuron recognize the non-emotion corpus, time, location, event, and related people, served as the current dialogue history and topic extension for future conversation. Later, the iteration layer employs 3 units: emotion decider, content corpus, and memory neurons. To deal with the previous emotion via the emotion decider, acquiring previous layer emotions to allocate single or mixed feelings and compete for storage history. The emotion deciders and contents corpus need to transfer signals to the memory neurons in the current layer and move them into update neuron in the output layer for output preparation. Finally, the single neurons from the update layer merges into the final output mirror neurons, generating considerable and empathetic responses to user in one turn. You can see this iteration might get several turns until user get resonating response. And now let's into the last part. This part utilizes previous background knowledge to design our protocol in dialogue system by using an example. A traffic service agent in mobile application to illustrate the flow in the dialogue system. The picture shows the protocol flow in dialogue system on a traffic service application. The definition of protocol flow is information exchange and transfer between users and artificial mirror neural network in the bottom of this picture. The top part of the diagram is the user interface. The left side is user response, and the right side is the agent response, while the button is artificial mirror neural network, served as receiving and dealing with initial utterance from the user by splitting the original utterance into the three main vectors: source vector, target vector, and emotion vector, as well as a filter to respond to a noisy utterance. For a traffic dialog system, the user can acquire a desirable traffic mode and a relevant hotel address, telephone number, and relevant information related to the place of interest information through communication with dialog system. User input is encoded into dialog agent vector for question answer visibly and exploration invisibly, and emotion vector for the appeasing user negative emotion through artificial mirror neural network, and noisy chat log filtered by the garbage collection module in the right part of vector. This diagram is only visualization of protocol. Now let's move to the mathematical representation. For this part, I use 6 tuple SAZROT, which is in the partial observable mark to decision process, and I give it new interpretation in terms of my protocol. Among the 6 protocol, the most two important parameter is Z and R. Firstly, let's talk about Z. An agent can perceive a limited set of states of the world. In this module, we build a sliding window based on the utterance of user over the time. With the uttering in the same sliding window, you can see the green window has a similar topic, and one of sliding window has the same content. In the protocol, the sliding window is a channel capacity for the data packets to recognize the topic in terms of user utterance in the period, and then maximizing the bandwidth of the channel B is expected. However, according to the channel formula, as channel bandwidth increases, the noises, in irrelevant information and cliche will also increases. For this property of convectivity, there is a point where the channel capacity will reach its maximum value, which is the maximum cardinality of our observation set and the property of through output of our protocol. And then the next important parameter is R, reward function. In my paper, I took advantage and came up with a delay effect since the dialog system needs to several training iterations for getting the final reward for resonating response to user. The following picture clearly displays this process. The red star represents the final return, and the blue circle represents the accumulated discount return of serious action in the dialog system. It indicates is a return held by the action executed by system after each of conversation. The darker the color, the higher the accumulated discount return, representing the property of delay reward in the reinforcement learning, as well as the latency of the empathetic protocol in this paper. Okay, that's the end of my talk. To conclude, the purpose of this paper is in the empathetic dialog system to extend the interpretability of emotion field and outlook the future mechanism in order to advise reader to pay attention to the interdisciplinary research between communication and artificial intelligence. Well, I have covered all the points that I need to present today. I'd like to thank you for taking time out to listen to my presentation.